Okay, we're going to take a look at 6.6. 6.6 is about solving radical equations. So a couple of things to keep in mind. Your first step is always to isolate the radical. Right? Isolate the radical. After you isolate the radical, the second thing is to eliminate the radical by taking both sides to the power of the index. All right, so we want to isolate the radical first, then we eliminate the radical by taking both sides to the power of the index. And then your third step is now you can solve. Fourth step, obviously, to check. So let's just jump right into some examples. We want to solve, how about the square root of x minus 3 equals 4. All right. So our first step is we want to isolate the radical. This here is our radical. We want to get it by itself. We want to isolate that. Right, so we need to get rid of this minus 3. We do that by adding 3 to both sides. We add 3 and we get the square root of x equals 7. So that's what I mean by isolating the radical. We want this radical, right? We want this radical symbol on one side of the equal sign. And we want it to be by itself. We can clearly see that here it is on the left side and it is by itself. Step number 2 says to eliminate that radical. So we want to get rid of this, and we do it by taking both sides to the power of the index. Right? Remember, if we don't have an index, there's no number in here, right? So that means that it's just a 2. Right? So what we're going to do is we're going to take this side to the power of 2 and that side to the power of 2. Because this radical and that power of 2 cancel, and it leaves us with x equals, well, 7 squared is 49. Right, so, and that's our third step, solve, right? So here, nice example, we got x by itself. You can easily check your work, right? So our original equation was this. And if we replace x with 49, I'm sorry, let me erase this. This wasn't a 49, that was 4, right? We replace x with 49, and square root of 49 is 7. 7 minus 3, we see it does equal 4. So nice first example. Let's take a look at our next example, B. How about the square root of x equals negative 3? All right, so once again, first step, isolate the radical. We can clearly see we have our equal sign, radicals on one side, right? So that's good. Now we want to get rid of this, so we take it to the power of 2. Take that to the power of 2. Radical and that 2 cancel. We're left with x equals negative 3 to the power of 2 is 9. All right. We check our work. We have a square root of x equals negative 3. Well, does the square root of 9 equal negative 3? No. So here we can clearly see we get no solution. Sometimes called an empty set. So a nice example there. How about example C? All right, we have x minus 7 equals 2, open parentheses, x plus 1. So we want to get the radical by itself. Here we see that we have this 2 in front of it. It looks like it's almost by itself. We can, if we want to, divide both sides by 2 to really isolate it. But if I divide by 2, I'm left with the fraction. So I don't like that fraction, so I'm just going to go ahead and just work with it like that. I'm going to say the radical is almost by itself here. I do have this 2 in the front, but that's okay. I just don't want to work with fractions. It has no index, so that means it's a 2, right? That means this is a 2. So what we're going to do is we are going to put that back there. We're going to take this side to the power of 2 and this side to the power of 2. Because now we're left with x minus 7 times the x minus 7. And this is now 2 to the power of 2. And then so is the radical. All right, and we'll see now square root and that power of 2 cancel. So here we're left with 4 open parentheses x plus 1. And on this left side, we got a FOIL. X times x squared. X times negative 7. Negative 7x. Negative 7 times x. Negative 7x. Negative 7 times negative 7 is a positive 49. All right, continuing on, we bring down our x squared. We can combine these two. Gives us minus 14x plus 49 equals, we distribute 4. We get 4x plus 4. All right, we see that this is now quadratic, so we want to set it equal to 0. All right, we learned this when we were talking about factoring. So we subtract 4x, we subtract x, we subtract 4, we subtract 4. We'll cancel over here. We're left with x squared minus 18x plus a 45 equals 0. And now we can solve by factoring. Should be a nice problem. This is a trinomial and a equals 1. So what's the product of 45? That sums to give us negative 18. How about negative 3 times negative 15? Right, so we get x minus 3, x minus 15 equals 0. And then from there, what we can do is we can set each one equal to 0. And solve. All right, so we get x to equal 3 because we add 3 to both sides. All right, add 15 to both sides. So we get 2 answers, but let's check our work. All right, once again, our original problem was what? X minus 7 equals 2 square root of x plus 1. Right, so we're going to check it for x is 3. We'll check it again for x equals 15. Right, so we replace x's first with 3. Uh, 3 minus 7, negative 4 equals 2. 3 plus 1 is 4. Square root of 4 is 2. And we can see that 2 times 2 is 4, and it is not negative 4. So this is false, which means that's not going to work. All right, let's do it again. 15 minus 7 equals 2 square root of 15 plus 1. 15 minus 7 is a 8. 15 plus 1 is 16. Square root of 16 is 8. I'm sorry, is 4. And we see that this does work. So even though we got two answers, right, we see that only one of them is correct. All right, so very nice example there. And I'll go ahead and do another video with some more examples.